Hello, my name is Subin Kim, and I will briefly explain about what I was engaged in during the summer, which is the Abstraction Reasoning Corpus project. The key aim of the ARC is to measure the general intelligence of computers. What is the definition of intelligence? We define the key as abductive reasoning, which is the ability to choose the most likeliest explanation from a limited set of observations. To measure such abilities, François Chollet proposed the General Artificial Intelligence Benchmark via ARC. ARC focused on measuring a broad form of generalization rather than task-specific skills. For instance, in example 1, we are given 3 sets of input and output grid. The goal of each ARC problem is to predict what will be the output when we are giving the 4th input. In this example, the rule is to count unique objects and select the object that appears the most times. As you can see from the examples, each set of problems has a unique set of rules that cannot be generalized. This way, we can measure how AI can effectively grasp the abstraction of each task with very small input. As an intern, I started out as studying related works as well as study reinforcement learning, which is the main algorithm that is used frequently in problems such as ARC. Other algorithms included programming synthesis or imitation learning. The main benchmark model that I studied was the one using program synthesis that synthesizes new programs for each new test set that is given. That way, even if the rule for each test set in ARC is different, it can synthesize new programs. There was also research that gathered human trajectories and linguistic descriptions about ARC dataset. Each node in above graph shows the state of the grid as the human participant modifies the output grid. The blue node is the starting point, and the green node indicates the correct output. As a result, we decided that we needed to gather 2 things. The original ARC problem set had too big of a state space because the output and input grid was not fixed. We needed a mini ARC dataset that can confine the state space to 5x5 grid and also meaningful in ways of gathering more data. We also needed expert trajectory so that we could use methods such as graph clustering to find new primitives. Currently, we are also thinking of using it for imitation learning to train RL model. That is why we opened Happy ARC Day and gathered mini ARC and also some human trajectories. We also had a great time introducing and learning about ARC together. During the Happy ARC Day, our team introduced the ARC project to participants and also practiced using the original ARC tools. We also received feedbacks about O2Arc tool, which we implemented. Then, we had a time generating and evaluating each other's mini ARC datasets. We also practiced coding the solutions to ARC problems and figure out some basic building blocks that can be used when AI try to solve the problems. To enable the Happy ARC Day, I programmed an interface to gather and evaluate the dataset and prepared some of the presentations. One of the great things about this internship was that I had an opportunity to meet with great-minded experts thanks to Sundong and people at IBS. One of the most memorable meetings was with Simon Alford, which was the author of the research about using programming synthesis to solve ARC. He gave hints about the limitations of his work, which was the implementation of RL model, and we could develop future plans of solving ARC based on RL. We also had a meeting with Professor Song-Soo Lim, who was an expert at graph and data mining. Through discussing and brainstorming about ARC, I also learned that I should not be afraid to pose my ideas and try out many ways during research. To sum up, what I had done during the summer was developing an interface for gathering mini ARC datasets and helped organize and process Happy ARC Day. I also pre-processed the valid mini ARC dataset afterwards and also participated in discussions with experts. What I learned through this experience was that I studied RL and related work such as Dreamcoder, bidirectional program synthesis, and language-based ARC, and also learned coding in JavaScript and CSS and backend interface such as Flask. I also learned to communicate with teammates. The future plan for the gathered mini ARC dataset is to make a benchmark dataset for future experiment to use as a criteria, and also use this to develop an RL model from the benchmark model from bidirectional program synthesis paper. We also plan to gather and visualize human logs and figure out how to use them. Thank you for listening to my summary of the summer internship.